Okay, so so far what we had done was a lot of circuit switching, and then of course a lot of basics about the packet switching systems. So basically the way I told was either you can use a crossbar and then you can build up a packet switch doing packet by packet scheduling, or you can build up a distributed system which is basically based on the self routing matrix, okay, which is a Banyan network technically. And you can use dist control routing. That actually means whatever tag which you are going to insert in front of the packet will be dependent on the output port address, and it will be same on all input ports. But if you are not using a Banyan Delta network, you are using some other configuration, then also on those Banyan networks also it is feasible, but for the same output the tag value will keep on changing depending on the input. That will be the only condition, but it is technically feasible to make the things. Now I am coming back to the telephony, ultimately why we were actually doing all this switching. So switches are technically built for two kind of systems. One is to create circuits or paths and then do the media transport over it. So this is what was conventionally done in telephony. So you actually create a path from source to destination and then the people talk. Second is, if I am going to build a packet switch, I frame packets, data packet, most likely that is the most common use. You will put a header, and from any source to destination you can do a end to end payload transport. But there is actually something more which also goes once you build up a circuit switching system, a packet switching system. You can build actually in layered architecture a complete communication infrastructure. That is what the internet actually does. So a packet switch is a very simple thing in that. So because that background is required, and if you have not done earlier course on digital communication networks, this will suddenly will become something different. So basically what I am trying is I am trying to start with IP telephony technically. So you need to understand how the internet actually operates, or TCP IP network, how does it operate. So of course the thing is pretty simple. You are going to have an abstraction of end to end. I am just doing a quick revision, and you will be transporting packets from source to destination. Reverse also you will be doing if it is a bidirectional line. This can also be a broadcast scenario. One person transmits a payload, it is being received by everybody and people can filter. Only thing is that these frames can be transported between two endpoints over a link, and these can be corrupted by noise sometimes. And if it is a wireless kind of channel where everybody is using same channel, there can be chances of collision. So we usually use an abstraction of medium access control if it is a broadcast network, and on top of it we take care of what we call the losses which happens because of the simultaneous transmissions. They somehow are coordinated, or you can build up a lot of other kind of access mechanisms. We now do technically all broadcast, all MAC protocols provide you nothing but an abstraction of end to end point to point link between any two endpoints. So broadcast network technically creates a fully connected mesh. Now over this link, so this actually takes care of, this abstraction takes care of even broadcast situation or a wireless medium or a Ethernet, whatever it is. Now you provide something called reliability using what we call window flow controls. So which actually means if I put in the, you put lot of packets in the queue, they will be delivered in same order. So if 1, 2 and 3, it will deliver 1, 2 and 3 in the same sequence. And there is going to be a parallel path in the reverse direction. In a broadcast network also, this is the what is being shown as an abstraction to the over data link layer. But honestly speaking, only one of these can transmit at any point of time when you look at the broadcast medium. And this actually means the bandwidth of multiple links in a broadcast scenario will be multiple virtual links. So you will be actually seeing, for example, if there are 5 nodes, the abstraction which you will get is this fully connected mesh. I think, yeah, this is the one. Yeah, it is connected to everybody. So, this is the abstraction which you will actually create, but they technically are nothing but they are all connected to a broadcast medium, but data link layer will see this, it will not see the broadcast scenario. So, that is the basically functionality of the medium access control. So, Ethernet protocol takes care of this. If it is a wireless, you can have all kind of variety of protocols. If we have WiMAX, we have Wi-Fi, all kind of things, they technically create this kind of scenario. If it is a WiMAX, you do not create this, you create a star, everybody gets connected to a base station. So, you create this topology and this controls. This WiMAX, GSM, all this will be this kind of structure. So, ultimately you will have end to end connectivity. Only problem with this, when you have this kind of scenario being abstracted into this form, is the bandwidth which is available on all the links, total sum of it is actually constant. So, if this one is using the bandwidth available for other links will become less, because total transmission bandwidth is common and shared by everybody, is a shared channel system. Same is true here in GSM. It is like when already 20 calls are being made, you cannot have more calls, because maybe all channels are busy at that point of time. So, more the channels are available, more bandwidth you can get actually. So, it is again a shared resource, and that is what also reduces the cost of the shared resource. So, once we have this abstraction, I get end to end reliable transport of packets in a packet switching system. Next abstraction we always say is we can actually create out of these point to point links an abstraction of a network. Any kind of topology can be created depending on how the people are reachable to each other. So, somebody wants to talk from here to here, he will actually do nothing but will form a packet, and packet will contain a header will contain the destination address, and this packet will simply be pumped. At every node that header will be analyzed and packet will be forwarded, and ultimately it will reach to the destination. There is no circuit being created here. Circuit switching, you are going to create the path first and then you keep on transporting your payload or data, whatever it is. There are other ways of also doing the things, but I am not worried about them actually as of now. Okay. Now, important thing is I want to do the voice transport. I have this packet switching system being created. We already know we can do this using your delta network kind of thing. Okay. And the header will be analyzed. So, usually before you have a delta network, when the packet comes in, there will be an interface electronics which will actually understand the complete header. It will also have the routing table, based on that it will decide on which outgoing port it has to go. It will insert the tag, packet will be routed there, tag will be removed because tag has already being used for its functionality of routing within the matrix, and then it will be moving over to the next hop. So, it will move from here to here, here to here, and so on. So, important thing, I need not do any signaling with the network, I have to just put the appropriate kind of header. Now, I have to set up the calls. Earlier days when it was circuit switching system, same thing, if this would have been exchange, I would have talked to this guy, said I want to dial to this number, it would have reserved the resource, this must have talked to this person, reserve the resource, the path once it is through till this particular point, it would have sent a ringing current here, ringing tone coming back, and when this guy lifts the handset, ringing current and tone both are stopped, final path is set up and they will start talking. At that point of time, billing will start. Billing is depending on the duration. Now, all that is gone. There is no, this guy is not talking, just forming the packets and pumping it in. But the question is, when you are going to hold a phone, you are connected here and this is a wire, this is a computer, this is fine. But with phones, this cannot be done. I can connect a phone here, tomorrow I would like to connect a phone here, I would like to have multiple phones connected at multiple places, and still I would like to make the call. So, how this will be done actually in IP network? Important thing is that the destination IP address and a port number are good enough to connect to a server. So, more details actually will come. Now, let me give an example of how this kind of thing happens in a IP call actually, how you can set it up. SIP I will talk about later on the actual standard, but first of all the call setup procedure. So, usually one of the important thing is, as all of you must be knowing, if you actually have a computer and if you have a program running there which can capture your voice and which can play back the sound coming from the other end. You have started a program on a computer. Okay. So, it is connected to a microphone, it is connected to also a speaker. So, whatever you are going to speak will be captured, can be packetized and can be sent to somebody, and whatever is coming from somebody can be played back. So, people thought of a lot of things and they said, okay, if somehow I know the other person's machines, this address will be an IP address. That is what is used in internet for addressing, and if I can run a small program here which is running on a certain port, okay, and then this is also connected to a microphone, this is also connected to a speaker, this is also connected on a certain port. So, in fact, if this person is initiating the connection, this port is immaterial. If this person is starting the connection, it will set up a TCP or UDP connections. UDP is a packet by packet system. You send a UDP frame, you build and you send it, even if it is lost, it is fine, you need not retransmit it. Okay. TCP, you make a connection, you keep on sending TCP frames, if they are lost, automatic retransmission will be happening after timeout. TCP also does something nice, that if the bandwidth available becomes very small, it will start transmitting at a smaller rate. There is a built-in congestion control which is not there in UDP. So, UDP is a datagram based system, TCP is a kind of a virtual circuit end to end, built on top of a packet switching system, both of them. Okay. So, only this port number if it is known, this guy can set up a UDP connection all the way to this person. So, it will get a UDP packets. So, I can put my all sound here, packetize it, transmit it over the network. These are all IP routers or switches, whatever it is. Whatever is the shortest path, it will take that shortest path and will reach here, or whatever be the other policies, it may be doing routing on the all other kind of methods. This end users are not bothered about that, they just create a UDP connection all the way from here to here. Audio is captured, packetized and sent all the way, this is received and this guy can listen whatever this person is telling, and similarly this program can also run in a different way. There are two channels you create in TCP, same way you can create two UDP also. This can also keep on sending UDP to these, and this can keep on sending UDP to this guy. Usually we will use UDP for most of the multimedia information which will be transmitted. Reason for that is, if I am speaking and you are packetizing my voice, sampling and forming packets, sending it, if some few packets are lost, okay, and if you have not done complete compression of the audio, the other guy will still be able to make out. See, if I am speaking whole sentence, something is not recorded in between, still you will be able to make out the sentence. We have lot of redundancy built inside the human construction of sentences. What electronic compression systems actually do is, they do not use that linguistic redundancy, they are not using that. They are only, for example, taking silence detection. When I am silent, that time they are not recording, okay, or they are kind of building a prediction so that I require less number of bits, only differential changes are being sent. But even if in a sentence, you can, if you know the previous sentence, you know the few words in current sentence, you can build on the base of context what I must have spoken in the current sentence. In fact, amazingly human mind is we actually do not listen to each and every word very carefully in the sentence. In fact, when you are reading a book, we also do not read each and every word actually. If you are careful enough, we actually jump over the sentences. Sometimes we skip the words, and we make from these what we call very fast scan of the words, we just join them and build up the meaning out of it. So, sometimes you might have seen that you have missed a knot written in text and you actually build up a meaning which was totally opposite than what was intended in the text. So, I think this is also one of the difference when you read especially the research papers, this is something which you have to unlearn. So, reading a novel and reading a research paper is different because of this. When you read a research paper, you have to read word by word, because it's go through so much of iteration and so much of compression that you cannot make out what is written in the research paper by doing this jumping through the words kind of method. But in a novel, this works perfectly well. And amazingly, if you read the novel second time, you will find out lot of things you missed out because you were jumping earlier. So now you will read a different sequence of words. So humans are much more intelligent in that sense. So machines don't do this thing. So that actually means if I build up a TCP connection, my some voice is lost, I do a timeout, retransmit, there is already so much of delay which will happen in that process. And by the time my other later sentences are already reached, you have already figured out the meaning. What's the use of retransmitting something which was lost? So anything which is delayed in real time multimedia is always useless. So by in principle, most of the transmissions are done over UDP. We don't do retransmissions for any audio or video stuff. And mostly we are talking about audio video, but there will be lot of other media streams which can also exist for communication. This is a very simple system. There is no switching is still happening amazingly. Switching is happening because I am now forming packets, and packets are being switched by the network. So digital switching is still happening, my voice is still being transported, but I think we will not be happy with this kind of system. I have to always either make a separate mobile call and find out what is your port number on which we can talk, and then set up the same thing in my software, you will set up in your software, or we have to at least know each other's IP address, and these IP addresses are not fixed for the users. When you are connecting at your home using an ADSL, every time you will get a different IP address, and this IP address has to be uniquely routable in the internet. If it is a private IP based system, then it cannot be. Most of the time in your houses you will actually have a telephone line coming, a ADSL modem. This will be acting like a what we call network address translation router, netting router. Okay. Actually, I am assuming lot of understanding in terms of networking, but if you do not understand a term, ask me, I will explain that, because I think all of you have not done the earlier course, and I have also not explained everything in the earlier course. Okay. So usually this the address which is assigned to the machine here behind the netting router is a private IP block address which is assigned by this machine. So when the packets are moving out, the source IP address is not this one, but this interface address, and it maintains a table that this was received from this one, and outgoing port number also will get modified. So usually this will maintain a netting table. So there is a private IP and private port number here, and for the outgoing side there is a one public IP which, or maybe few set of public IPs depending on how the netting is configured. So usually in households this will be only one single IP which will be used. In institutions sometimes we use more than one. So because now here the range of IP addresses which can be put in the table is much larger, so I can use less number of ports. I will use less number of IP addresses which are available on this. These are unique IP address across the globe. Okay. At any point of time only one machine can use that IP address. So for example 202.141.40.215 which we are using for our Brahaspati server is a unique IP address. Nobody else in the world is going to have this IP address. So that is the way they have been arranged in the internet. So we will keep on using those IP addresses here, but they are less in number, maybe only one, but I would like to do a TCP connection for a telnet, I would like to do a voice over IP call, I would like to do a browsing. So many ports will be open, say 5 ports, there can be another machine here sitting in your house, and there also somebody is doing voice over IP and whatever it is. They might be actually doing the same IP address, same port numbers also may be used with different IP address. See, for example, this might be using 172.26.82.1, this might be using 26.82.2. So, this here the browser might be using same, say 16,536 number port, this is also 16,536 port. So, when this guy is going to send the same packet out, it will use same IP address. So, but these two connections have to be identified. So, port numbers which will be used will be different actually for the outgoing side. This will be source IP address and source port number will be modified when the packet is going out. Okay. So, Google or whoever server, whichever server you are going to use will be not seeing your IP address, this private IP block they will not see, they will see the IP address which is here. Because if they start seeing this IP address, in the reverse they cannot send the packet because those packets will be dropped. So, thumb rule is if in internet any router, if it sees a packet containing in the destination address a private IP block, an IP address from that range, it will simply drop the packet, it will not route it. So, reverse when the packets will come, they will come for this IP address. So, again the same table can be looked and destination IP address and port number can be updated or modified, and then packets will be routing appropriately to different machines. So, you can run multiple machines behind a netting router because of this. In IPv6 even actually this is not required, each one of them can have globally routable IPv6 address is possible. So, their address space is huge, there is only a problem in V4. Okay, V6 you actually get /64 address for everybody, which is a huge number. Okay. So, first 64 bit out of 128 are going to be used for network address, and you can have 2 raised power 64 hosts sitting in your subnet in your house. So, your phone, your TV, your remote, whatever you have, your watch, everything can have an IPv6 address, and all of them can be routed through one single router. So, that is kind of capability which has been built. Okay. So, now, so there is a publicly routable address, somehow it has been managed. Call setup is still an issue, I have to do that. So, what could be the idea? You have to tell me what will be the logical approach for you. Telephones numbers are always unique. Your mobile number remains the same wherever you go, is that number is your identity. So, one thing which is sure is I certainly cannot put this IP address as an identity of the person, that is not possible. Because if I am connected over a Wi-Fi, I might latch on to another Wi-Fi. If I am actually using GPRS or some other thing or a 3G connectivity or WiMAX, I might be moving in a train and maybe attaching to something else, I might get a different IP address allocated. So, there is a mobility thing aspect. You may actually go from this room to another room and connect a phone there. So, this will not work, but you can always check your emails wherever you move, how that happens. Your email has what kind of address? It is always some user @ some domain name. So, maybe I can use something very similar.
That is space we use on some particular server, that is space we use.
Yes, so that actually means we require some server, and I have to tell I am so and so person and I am here as of now. So, when this you are touching your phone here, I need some kind of a server running which should be known to this person. Everybody knows where is Google, so you can always check your email. If you run your mail client, you are always writing on that, in the Thunderbird you will be writing your, for example, imap.googlemail.com or imap.gmail.com, that kind of thing you must be writing. That is IMAP server, and that is uniquely resolved to an IP address. So, in fact, there is another thing, something called domain name system. So, but in internet, as far as actual communication happens, this happens on the base of IP addresses, either 128-bit IPv6 address or 32-bit IPv4 address. But humans cannot remember those numbers, so we usually go for domain names. So, every machine is going to have a name and is registered under a certain domain. So, the master or root domain is root, which is known as dot. Under that, then there are many domains which have been created. So, India is using .in domain. So, last dot if you write, it is fine, if you do not write, then also it is fine. So, it is under root. Within that, then we have edu.in, we have ernet.in, we have ac.in. So, in fact, ac.in is what IITK is using. Our servers for Brahaspati and Brahaspati Singh are using ernet.in. Then within that we have IIT Kanpur, IITK. Then I can use machine names. So, when I use www.iitk.ac.in, this is actually the machine name. So, when I resolve this query, so you can actually go into a Linux box and you can use either NSLOOKUP, which is the old utility, or use dig and give this name, you will get an corresponding what is the IP address allocated. Or you can also go to www.traceroute.org, give this name, and the machine server there will identify what is the corresponding IP address. IP address will always be 32-bit. These names can be very long. Okay. So, we have been using, for example, bresvn.ee.iitk.ernet.in. So, this is when you are within IIT Kanpur, when you are ac.in here. When you are outside IIT Kanpur, I have been using iitk.ernet.in. In fact, there should be a final dot, is directly an entry under the root. And worldwide there are certain number of root servers which are running, which runs all the time, is run by various governments, and they always synchronize. Those are dot servers, root servers, and root server entries are always there in your /etc directory. You can actually get the file in your Linux box where you will see the listing of all these root servers. Okay. So, it actually comes in the configuration of the named. Named is the utility which is used for this purpose, DNS. So, you can run even your own DNS. AC is a domain name. Under India, this is also ERNet is also registered as a domain name. So, all the machines which are part of ERNet are going to, so whatever the IP address allocation for ERNet has been given is given there. So, ERNet runs their own DNS server. So, how it happens? I want to search for this particular IP address for this machine. So, I know this is the machine for which I am looking. So, I will go for a entry for, I would like to find out if I know the DNS of iitk.ernet.in. If I do not know, what I will do? I have my own local name server. Everybody will be having a local name server which everybody configures. So, all of you also have configured 172.31.1.1 in IIT Kanpur and 1.130. There are two name servers which everybody configures. So, your machine actually talks to that machine, can you give me the IP address of this particular name? It will say what is my domain name. This particular servers are responsible for iitk.ac.in domain. So, when you ask for this, you can actually access this from your machine. So, it will find out that iitk.ernet.in I am not for that. So, I have to search for ernet.in entry. So, that server 1.130 will talk to ernet.in corresponding DNS for that. Okay. So, it can, one of the ways is it can directly go to the root, find out what is a .in server. .in is common, so it will go to .in server, find out what is the corresponding DNS for ernet.in, talk to him, find out what is going to be iitk.ernet.in DNS server. This is also running in IIT Kanpur. So, we have done a short circuiting. So, we have already told that iitk.ac.in server For iitk.yarnet.in, this is the server. So, it actually makes sense the request there, which then in turn tells what is the IP address for this BRIE SVN. This we do not manage, this is managed by Yarnet team. So, when we wanted to put our 202.141.40.215 entry there, we have told them, requested them, and they have put the entry. For this one, for electrical engineering, all machines names, this is the we actually maintain. But we have informed that iitk.ac.in domain server that for any name which contains E, you have to contact me. So, it keeps on fetching entries from my side. If you do not know anything, just simply connect to a root server, and root server will tell this domain, then from there you will get this domain and this domain, so on, and you can ultimately get the IP address of the machine. Now, this is a very important concept, and that is what we are going to use. So, these are all hierarchical, but they are all distributed systems, a distributed database technically. You can do dig. Dig is a command which can actually even tell you the complete chain of events. There are two ways you can directly connect to the root, or you can ask your name server, in that name server will contact his further parent domain, and he can contact his further parent domain till they get the address. Addresses are fetched back, and then you can get, that is one way of doing it. Secondly, you ask this guy say I do not know, but my parent is this, you talk to him. I can talk to the parent, so I can keep on talking till I get the IP address. Every time we make a separate query till it gets resolved. See, sometimes when you do ping or telnet, it will not work, because your machine has fired a DNS query and it is timed out, result has not happened, but that DNS meanwhile actually is already fired up another query. So, next time when you will do the same ping, you will immediately get an IP address, because each one of them also maintain a local cache. So, some DNS query is not being used for a long time, it is automatically flushed out from the cache, otherwise it is kept in cache.
So, how we decide how much database should have, server should have? You can distribute database as there.
For your domain, you are responsible. How you manage, it is your domain administrator will take care of this. So, for all IIT Kanpur machines, iitk.ac.in is computer center takes care of that responsibility. Within electrical engineering, all machines, I take care of that responsibility, or my lab people will take care of that responsibility. So, if you want to actually have your own name, so you have a machine in, for example, say 305, you are working on that. You say I am fed up, whenever I do telnet, I have to remember my IP address. Can I use something called my name itself instead of that thing? So, you can always say I would like to put my machine's name as Rameshwar, rameshwar.e.iitk.ac.in. So, I will take your IP address and your name, and I will put in my DNS entry of D is DNS, I will make an entry there. I will create an entry because I am the admin for that, and then it will percolate all the way to the IITK domain also. So, anybody can connect to you, but unfortunately we are using private IP block. This entry is never propagated outside IITK, but within IITK we are percolating all the entries. We are taking entries from outside world if we are not using proxy. So, remember, if you are using netting router, we have to use 172.31.1.130, which is netting, which is a DNS which is running outside. When you are inside, you are not using that one actually, and you cannot get IP address of gmail.com unless you put that as a DNS, because that is an outside IITK. So, that is how the netting will work, because you require an IP address of Gmail in that case. So, now what we have to do is we have to put a server here, indexing server we call it, that is a term which is used. Usually there will not be one, but there will be multiple of them. I am first of all talking about a principle, okay, of how this can be done. Now, if these both guys knows about this indexing server, what this guy will do? It is a directory. The way we have a DNS, it is a directory system. You want to make a phone call, you can always keep a phone number, what is the corresponding IP address, phone number, corresponding IP address and port number, maintain a list. So, when I want to make to a certain call to somebody, I will just make a query here, I want to talk to this particular phone number, what is his current IP address and port number on which he is listening. Once I get that number here, I can just make a TCP connection or UDP connection to that guy and start talking.
How is register that person current IP address? How this server register?
Yeah, that is the next question which I am coming to. I am building upon this. Okay. So, indexing server kind of resolve this particular issue of mobility. So, if I am moving my IP address, whenever my IP address changes, I can have some mechanism to talk to this guy, talk to this server and update my entry. And this entry has to be updated say every 30 minutes. If it is not updated, I will remove the entry. Probably you are not alive, your battery is down or you are disconnected. You have to periodically keep on updating. Our mobile phones actually do that. Every 6 hours they re-register periodically. If your mobile phone does not get an opportunity to actually turn off the registration, you just take the battery out. So, your what we call indexing server which is maintained in GSM will maintain the mobile phone's entry still, because mobile phone is purely passive, it is not communicating back periodically, it is only communicating every 6 hours or whenever the local area identifier LAI changes, is a mobility handling technically. So, location area is there are multiple BTS, they will have one particular ID. So, they have one common location area identifier. So far I am within those BTS's range, I need not transmit back. If that LAI changes, then I figure out my LAI changes, location area identifier has changed, I will again send a request and update my new location area to the server, indexing server of GSM. A different name is actually given to that. Okay, we do not call it indexing server there. Okay. So, this is I think known as home location register HLR. Okay, is a home location register there. So, remember the same functionality and different people will use different terms. Skype uses altogether different term, Google uses a different term, SIP is going to use a different term for this, they call it registrar in SIP. Okay. Skype I think calls it as a, there is a different term, master, no, is a master, it is not a proxy actually, they use some other term. For different actually there are lot of systems which have been built around this mechanism. Okay. So, this guy will essentially talk to him, keep on updating, that is very important. So, all numbers will keep on updating, and why to use the numbers? Numbers in numeric coding is a legacy of telephony. Why we have telephone numbers? Because that time it was required, there was no other way a port or a device could have been identified. So, just to be backward compatible I am talking about numbers here, but I need not have numbers. If I can use email IDs for talking, now that is pretty common, we all do messaging over emails, that same email ID, or Google ID lot of you have been using over Google messaging system. So, why to even making a phone call do I require that? I don't know. On Skype I do not use phone numbers, I still use that Skype ID, or Google chat, voice video chat I use a Google ID, you do not require numbers, I can directly use names. I only require an identification, who is this guy, an unique ID, and why your ID cannot be used by somebody else on Gmail? Because there is a domain which is identified gmail.com, within that if I have used Vayansing69, that Vayansing69 will not be given to anybody else, that is taken care of when somebody you try to choose a new name at that point of time. You cannot even create that thing as an alias, servers has to ensure that. So, here if I am going to put numbers, you can arbitrarily choose a number and register here, how that will be stopped? Mobile phones use a very different technique actually for avoiding this, but still this can be done using SIM cloning. It is possible to actually have same number running simultaneously on two different SIMs handsets. But only problem is when both of them will try to register, only the entry corresponding to the latest one will be there. When other guy will try to register, it will override the earlier entry. So when the SIM is cloned and somebody is trying to make a call, you might end up in calling the wrong guy who has got the cloned SIM, but both of them will never get the phone call simultaneously. Unless there is only one situation. What is that situation? They both are in same location area, which is going to be a rare thing to happen actually. So again, number itself is not good enough. I need to even identify this server, and we need not have only one server across the world, we can require multiple of them. So we have to come with the concept of domain name. Your emails are always, as for example, my email is this. I can use this domain as the domain of the server. So this is a service provider which is going to be there. Almost Skype is only one single service provider all across the world. So we do not have a domain name is not listed there. Gmail also similarly domain name is not listed. But think of a situation when you are using your Gmail ID, Google chat, and you will be able to connect to a Skype chat, Skype client for somebody. Then how you will call the guy who is on the Skype? You simply cannot use his Skype ID, you have to say whatever is the ID @skype.com. Domain has to be specified. In fact, internet relay chat system, IRC chat system, this is what actually is being used. So there is generic chat clients which are available, which can, most of the chat protocols are in open. So we have to specify even domain name. So this is what is going to be your URI, and depending on what kind of signaling you are using, you have to specify that. Okay. So SIP thing, when SIP is going to be used, it will be SIP colon as this will be the domain kind of thing. But anyway, that is a different thing. Now coming to the basic concept, not to the detail of SIP, can anybody keep on updating this entry? No, I think they should never be permitted. If I am the guy who actually is going to have a certain number or certain name, is only I who should be able to update this entry. And for the timing, all of you have been assuming that only one device should be able to make the update in this entry. And this entry simply says for this particular user, this is the corresponding IP address. This is slightly old thought in telephony, because that is the way telephones actually have grown. But think of a situation, my home phone, my mobile phone, maybe 2 or 3 mobile phones, my PC, my office phone, all of them are registered, all of them actually will keep on updating this entry. So this guy can have for this user entry number 1, entry number 2, entry number 3, entry number 4, I can have multiple entries, and all these devices will keep on updating. And it is possible that when somebody wants to make a call, he will come to this person, will get the indexing entry, and he will get so many IP addresses, and then he can try one by one all of them, he can try all of them simultaneously. One of them picks up, it dissolves everything else and makes up the communication. So all your phones will ring simultaneously, or there can be priority. But who is now setting up the priority is this client. Now this actually design, somehow I am not very happy. I should be very simple, I should talk to only one person. So can there be an abstraction of representation of this user which can have multiple instances running, and only one single abstraction which is available to somebody who wants to make up a call. So this actually can be done, and that is what exactly SIP design actually has done. This is mimicking nothing but registrar. I can build something like a proxy. So, this actually does happen in Skype, if you carefully observe. If you actually, have you ever run Skype client or Google clients, multiple of them simultaneously, and then try to send up a call to this guy who is logged in at multiple places? You actually, the line actually rings at all the places simultaneously. Well, that is a by default design, they do not have a configuration thing to set up the priorities or ring for 5 rings and then actually move to next one. There is no ringing current and tones, usually speaking, in this scenario. I do not need to keep on transmitting my ringing current being packetized and transported as a voice packets all the way to other end. So, they all generate their local stuff and they locally shut it down, only for the voice thing they transport the packets. So, now one thing which is very clear is that these clients will register with a registrar, and usually this client will also register with this same registrar. So far what we were doing is, each guy was searching only for the entry, finding out the other thing, then directly talking with him, setting up the call, and once the call has been set up, they were talking. But there are a lot of problems in this. Somebody can easily change the personality. I can always spoof as somebody else very easily in this kind of scenario. Security is not there. So, how to maintain the security is an issue. I should never ever tell this guy, unless I authenticate him or anybody who wants to actually make a phone call to me, I should not permit anybody else to get the IP address. Somebody from the public should not be able to get my IP address and connect to him, because he can tell whatever he wants. I will never be able to identify him, there is no caller ID, and calls need to be identified from where they are coming. So, the only way I can solve this problem is if I restrict only calling between all the guys who have registered only on this system, then only it is possible.
Then again, not a good security.
Yeah, it's not.
Because ultimately, okay, within a domain I am allowing, but I don't know what within a domain I do not allow the X, but 10% I only want to allow 2%, not the rest of it.
You can actually, you can tell this all this configuration to the registrar. Registrar can maintain. At least before a call comes in, you can always verify about this person from here. What is his identity?
So this is already implemented in SIP.
No, SIP does not work this way. SIP is different. See, I am evolving still. I have started with the fundamental problem. I am evolving a system.
The basic fundamental, who will own the responsibilities if my identity with somebody here using data?
Yeah, that is the question. So, SIP server, I call it now the telecom operators is essentially have to run this server. Currently they run HLR and you only buy the SIM and you authenticate with them. Same way you will buy an identity from them and you will be registering with your server or whoever is your service provider. But if there is going to be only one server and only one service provider within India, I think that is not okay, all across the globe. So, Skype for example is one single service provider all across the globe. You do not figure out where his server is indexing server. That is a different question. It is maintaining a distributed server cluster of servers all across the world. You always authenticate. How do you know that when you are clicking on Viancing which is coming on Skype ID and I am actually Viancing? How you are so confident that the message which you are writing is going to the right person, or it is going Google chat when you do, it is going to the right guy? How do you know? Because IDs are unique and there is only one service provider. Unless service provider does a problem, somebody there actually tampers with the security, security is going to be maintained. So, this by restricting the domain, but voice telephony cannot be implemented that way in IP. I need to have multiple operators should be possible. Why I have to always have one client of Skype and one client of Google chat or Google voice? Why that has to be done? Why I can't have a single client? And I am taking with Skype, but I can still talk with somebody with Google. And how this peering will be done? the Google and Skype has to talk to each other, and as of now they do not use SIP, they are based on their proprietary signaling format.
So this is similar to mobile number portability. We have to use a single number and multiple operator.
No, that's not possible. That's unfortunate thing. That's not possible because your IDs will be something like this. You are saying I am going to still maintain Vyansing at iitk.ac.in, and this email ID I should be able to work even with Gmail. Now there is a way to work out actually. They will create another email ID and this will be aliased, but earlier domain also it is going to be locked. So either that domain should also be owned by Gmail. So lot of academic institutes do create their mail accounts in that fashion. So their actually mail account for the whole academic institute is running on Gmail only, but their email IDs are, for example, in IIT Rajasthan, that is the way it has been done, is iitj.ac.in, but it is running, the whole mail system runs on Gmail, because Gmail provides for free for academic institutes.
Again, we are using a single client.
And the way it actually works is very simple, is that iitj.ac.in, there is a mail MX record, mail exchange record in the DNS server. So DNS server of iitj.ac.in MX entry is actually is pointing to a server which is there at Gmail, and Gmail maintains this whole thing user@domain as the complete user ID. I think that is what is actually being done, but usually @ cannot be used in user ID, so they must be replacing it dynamically there. So but MX record entry has to be changed, but Gmail can also do it for you by creating its registering your own domain. They also are the domain registrars. Okay. So now let us see where we have reached. So we have come to the concept of registrar. We are trying to look at security, but restricted only to one single domain. Now we actually have realized that we require multiple domains. Single domain will not work, and we need to still have the security. So we have to build now from here onward to what we call the telephony system, which will work over IP. So what I will do is, because more or less systems are very similar, I will once in a while will come to the Brihaspati sync design, because that also conceptually works in a very similar way. Okay, but we do not use, we use an indexing server which is our Brihaspati 3 server only. So all your IDs, that email ID and passwords are the same thing which are there indexed. So whenever I will announce a live session, those live sessions are gets indexed here. So those are also indexing server entries. Now those are a different kind of system. Now, I am not talking about telephony, I am talking about a conferencing system. So now that was something which was very bad in the earlier design. Earlier telephony was very restrictive. So as far as the session management and creation and handling is concerned, we do not worry about whether it is IP telephony or whether it is a conferencing or it is a multi-party video game or it is some other kind of thing, does not matter. So far I can create a session of any number of users. So how to set it up, that is the question basically, and it is with proper authorization and proper authentication. So if you join a session and if you say I am so XYZ, you should be XYZ and you should be permitted to participate in that session. There are two things which are very important. Okay. So this is what basically has to be done by everybody, and since you are going to have multiple operators now connecting, they also have to peer with each other for and securely, not insecurely, they have to do it in a secure fashion. And how security will be identified? The key thing is security certificates. How I know that you are so and so? You can always show me your ID card which is signed by the director, and I remember the director's signatures. So if they match, you must be so and so.
You are talking about SSL certificates.
Security certificates, right? Not SSL is secure socket layer, which uses security certificate, but security certificates are different. Okay.
That is
X.509 certificates we call them, I think. So, but these people can also do peering with each other. See, because whenever I want to talk, say I am in domain of iitk.ac.in. So, very soon we will be actually having similar structure in IITK also. So, slowly we will do away with the phone numbers. We will come with a unified system where your email itself can be used for doing the even interaction over a phone call. So, there will be phone handsets which will be like computer. So, another 2-3 months down the line they will be all deployed.
When we have a single client, multiple operators are there, we are using single client.
You are using single client, you can only connect with one operator with one ID, not with multiple of them.
So my question is, when we have a single client, do we have the same security policy with multiple operators?
You only connect with one operator, other operator will not recognize you.
That is the same thing.
Even at other times, unless you register with them, you pay them or get your separate certificate. There is a procedure for that. The way you get your SIM cards which are there for authentication, similarly you will be issued security certificate by the agencies. Let me come to how the Skype actually works, then you will understand. Skype use, I think, very similar thing. This is a guess, I have not seen the Skype documentation or design, but we have been using similar concept for our peer-to-peer systems. So, I will continue with the same thing tomorrow morning.